Okay, now we're going to talk about translated graphs of sine and cosine. And so we're going to take the mother functions, sine and cosine, which we just graphed in the previous part, and we are going to start compressing them and stretching them and shifting them. And so if we look at the equation for a translated graph for sine, we have y is equal to a, then sine, and then b times x minus c, and then plus d on the outside. A is the amplitude, so that will tell us our vertical stretch. How high does it come out from our midline? B is going to help us determine the new period of the shifted function or the translated function, and we're going to use our knowledge of horizontal compressions and stretches, right? Because remember, thinking back to our translated function rules, if we have a constant in front of the x, that tells us if it's horizontally compressed or stretched. The c is going to be if we have a horizontal shift, either left or right. If we have a minus c, then that means we're going to move it to the right. If we have a plus c inside the parentheses, that means we're going to move it to the left. If you think back to our graph shifting rules, x's were always anti-intuitive, and if you saw a minus in front of it, you wanted to move it to the right, and if you saw a plus in front of it, you wanted to move it to the left. Now, a lot of times this will also be called the phase shift. So keep that in mind. And then D, the last item, is going to be on the outside of the function. So if we have some function f of x and we add a number to it or we subtract a number to it, if we think back to our translation rules, that would be a vertical shift up or down. We're going to use our knowledge, our past experience with translating functions in general, or the translating rules, in combination with the information that we're learning now of the sine and cosine functions to put that together to graph our translated functions. If I look at this equation, 6 is my A, so that's my amplitude. So that means it's vertically stretched. So from the midline, I'm going to come up 6 and down 6. So typically when we look at the mother function of sine before it's translated, we go up 1 from the midline and down 1 from the midline. And in this case, it's been vertically stretched, so the amplitude is 6. Now, for the period, to find the period of the translated function, we're going to take the original period and divide it by our value of b that's given in the problem. Since this is a sine function, when we look at the mother function of sine, our period for the mother function of sine is 2 pi. And our value of b in this case is 2. So I'm going to take and divide by 2. So my new function, or my new period for my translated function is going to be pi, which means instead of it coming out when we look at the sine function, instead of it repeating every 2 pi, it's going to repeat every pi. So basically what we did is we shrunk it in half. We horizontally compressed it by a factor of 2. We squished it in half. In order to figure out what c is, I need to put it in this form where b is factored on the outside of the parentheses. And that will help me determine the phase shift on how it's horizontally shifted. So I'm going to rewrite this as 6 sine. I'm going to pull out the 2. And when you factor, basically what you're doing is you're dividing everything on the inside. So I'm going to take 2x divided by 2 is x. So what's left over on the inside is x. When I take a 2 out of the pi over 2, I'm taking pi over 2 and dividing by 2, which will give me pi over 4. So my value of c tells me, since this is a positive here, I know that I'm going to be moving, my whole graph is going to be moving left pi over 4 units. And my phase shift is negative pi over 4. Because we use the opposite of what's inside here. Now, to figure out the scale, how are we going to scale this when we graph it? If we look at the graph of the mother function of sine x, and we use our key points. Remember we said we have 5 key points that we're going to use when we translate this. So we have the start and stop points, the maxes and the mins, all the key points, and then the midpoint. Notice that that's split it up into 4 sections. 5 points, split it up into 4 sections. I have 1, 2, 3, and 4. So this is section 1, section 2, section 3, and section 4. So wherever I start and wherever I stop, I want to take the length of that and divide it by 4. Whatever the length from the start to the stop point is, and divide that in 4. So to take a nice easy example, if I was graphing something from 0 to 1, and I wanted to break it up into 4 pieces, I would take a length of 1, because 0 to 1 has a length of 1, and I would divide it by 4. So I'm going to be graphing on a scale of 1/4. So that's the same thing we're going to be doing here. We're going to find the length of the interval, and then we're going to divide it by 4. Since the length of our interval will be 1 cycle, I'm going to take my period, and I'm going to divide by 4. In this case, my period is pi for my new function, so my scale is going to be pi over 4. Now, when we look at our key points for sine, I'll do the key points in blue. These are the points in blue of the mother function. We would graph it at 0, pi over 2, pi, 3 pi over 2, and then 2 pi. These are going to be the key points. Now, because we have, this was for the mother function points, because we have a shift to the left, we're not starting at 0 anymore. So for the translated function, if I start at 0 with my mother function, but I move to the left pi over 4, that means now I'm starting at negative pi over 4. So in red, I'm going to do the translated functions. And since we're going on a scale of pi over 4, I'm going to keep adding pi over 4 to get the next 4 key points. So just as if we go back to that example, if I'm graphing something from 0 to 1, and I want to break it up into 4 chunks, I'm going to keep adding 1/4. That's my scale. So if I start at 0, my next point is going to be at 1/4. Then my next point will be at 1/2. Then my next point will be at 3/4, because I keep adding that value for my scale, that 1/4. So in this case, we're adding pi over 4. So if I start at negative pi over 4 and I add pi over 4, that's going to give me 0. And then if I add pi over 4 to 0, that's going to give me pi over 4. And then if I add pi over 4 again, that's going to give me pi over 2. If I add pi over 4 again, that's going to give me 3 pi over 4. Now the entire length from start to stop, if we did this correctly, should be a length of pi, because we said our full period for the translated function was pi. So if I go from minus pi over 4 to 3 pi over 4, if I check that length, it definitely is pi, and it works. Now, when we look at the graph of the mother function of sine, when we start, we have the point 0, 0. So we're going to start at 0, 0. So it hasn't been shifted up or down, so I don't have to add something to 0. So I'm just going to start here at 0. Then the next mother function point for sine is 1. So we go to 0, then we go up to the max 1. But since this has an amplitude of 6, it gets stretched not out to 1, but it gets stretched out to 6. Then we come back down to 0. The next key point, we're at our minimum value. So normally with the mother function, we come out down to -1, but because this has an amplitude of 6 and it's been stretched vertically, this is going to come down to -6. And then the last key point is back up to 0 again. So these are the points I'm going to use to plot my translated function. 1, 2, 3, 4, 5, 6. So it's going to come up to 6. 1, 2, 3, 4, 5, 6, and down to -6. Now, for every 2, since I'm doing this on a scale of pi over 4, for every 2, I'm going to make that pi over 4. So I'm going to start here at negative pi over 4. Then I have 0. Then I have positive pi over 4. Then I add pi over 4 again, that gives me pi over 2. If I add pi over 4 again, that gives me 3 pi over 4, which is where we stop. So now I'm going to graph my key points. At negative pi over 4, I get 0. At 0, I come all the way up to 6. And at pi over 4, back down to 0. At pi over 2, down all the way down to -6. And then back up to 3 pi over 4. So there is the graph. Whoops, I didn't have a very steady hand there. So here is the graph of one cycle of 6 sine 2x plus pi over 2. Now I'm going to next show you how you can check this on your calculator. Okay, so to check this on your calculator, the first thing you're going to do, make sure you clear out anything that you have in there already. Then we want to make sure we're in radian mode. If you're not, just switch it from degrees to radians. Then what we're going to do is we're going to enter in, oh, I'm in polar mode. Hold on a second, let me check that. Okay. We're going to go ahead and put in our equation. So the function that we just did was 6 sine, and then in parentheses, two x plus pi divided by 2, close parentheses. Now, to check it, to make sure we've got the right cycle, or the right first period, we're going to go to the window and we're going to adjust our screen to see if we did this correctly. So I hit the window button. Our x-min, since we shifted over to negative pi over 4. So normally with our mother functions, we start at 0, 0. But we shifted to the left pi over 4, so that's our new starting point. So I'm going to put in for our minimum value for x as our starting point as negative, make sure you use the negative and not the subtraction button, negative pi over 4. Now it will automatically change it to a decimal for you when you hit enter. Our maximum value, so at the end of our cycle, the last point of our cycle we said was 3 pi over 4. So I'm going to put in 3 pi over 4 for our x max. So this is our horizontal distance. We're going to go from minus pi over 4 to 3 pi over 4 for our cycle. Now our scale, we did it on a scale of pi over 4. So where it says x scale, I'm going to put in pi divided by 4. Our y value, we want it to go up to positive 6 and down to negative 6. So our y min is going to be negative 6. That's our lowest point for our y value. And our highest point for our y value should be positive 6. And we can do that on a scale of 1. Now, once I set up the window and hit graph, if we see what we just drew, the full complete cycle, then we know we've done it right. So I'm going to hit the graph button, and there's one complete cycle of sine where it starts on the x-axis, it goes up to the max, it comes down to the min, and then it comes back up to the x-axis. So we know we did this correctly. Okay, let's move on to the next example. We are going to graph 7 sine 2 pi x minus pi. So let's first write it in the form like this, so we can identify all the major pieces. So that means I'm going to factor out the constant in front of the x, which is 2 pi. And when I factor out the 2 pi, that's like dividing by 2 pi. So when I take 2 pi divided by 2 pi, I get 1x left inside. And when I take pi and divide by 2 pi, I get 1/2. Okay, so now we'll be able to identify everything. Notice there is a value of 0 for d here. So we're not doing any vertical shifting, but we are going to do some horizontal shifting and stretching. And I know that because of this and this. That's a horizontal stretch. This tells me I'm going to have a horizontal stretch or shrink. And this tells me I'm not going to come out to 1 anymore. I'm going to come out 7 from either direction of the midline. So my amplitude is 7. Instead of coming out 1 in either direction, I'm going to come out to 7. My period, I'm going to take whatever the original period is from the mother function and divide by my value of b. That's the number that's in front of the x. Since this is a sine function, my original period is 2 pi. And then I'm going to take and divide by my value of b, which in this case is 2 pi. Right, here's my b. Let me point that out to you. Right here, that's my b. Right, the b is what's in front of the parentheses or in front of my x. My phase shift is basically my horizontal shift. That's this right here. Because it's a minus 1/2, that's telling me I'm going to shift it 1/2 to the right. And my scale is going to be whatever the new period is for my translated function divided by 4, because I want to chunk it up into those 4 pieces. So let's back up and look at our cycle for the mother function before it's translated. So here's what my mother function looks like before it's translated. Here are my key points. And it breaks it up into 4 chunks, right? This chunk, this chunk, this chunk, and this chunk. So I always want to take whatever my period is and divide it by 4 so I know how to scale it. So that means my scale is going to be 1/4 because my new period, let me actually put new period here so you have it in your notes. Your new period is 1 for the shifted function, and I divide by 4. Okay, so normally, when I look at my mother function, normally we start here at 0, 0. Because my phase shift is telling me we're pushing the whole function 1/2 to the right, instead of starting at 0, we're going to start at 1/2. And then I have to keep adding 1/4 because my scale is 1/4. So if I add 1/4 to 1/2, that gives me 3/4. And then if I add 1/4 again, that gives me 1. If I add 1/4 again, that gives me 1 1/4, which is 5/4. And then if I add 1/4 again, that gives me 3/2, 1.5. Okay, so normally we start at 0, 0. There's no vertical shift, because if we normally start at 0, 0, and there was a vertical shift and we moved down 1, then this point right here would be -1. But there's no vertical shifts, and we're not reflecting this or anything. So we're going to still have the same values for y, basically. The next key point on my mother function is my maximum point. In this case, because my amplitude is 7, instead of coming out from one unit from the midline, I'm coming out 7. So I'm going to have a maximum of 7. Then my next point, I come back down to 0 again. And then my next point is the minimum value, which would be down to -7, because that's my amplitude. And then my last point is to come back up to 0 again. If you notice, the distance from 1/2 to 1.5 is a cycle length of 1, which we should have. My period has a length of 1. So it's a good way to check to make sure that you added your scale properly to get each of those points. If you take your ending point and you subtract your starting point, you should still get the length of your period. Okay, so let me draw my scales. Now on the vertical scales, I'm going to go by 2 since we're running out of room, since we go all the way up to 7. I'm going to make this 2, 4, 6, 8. 2, 4, 6, 8 negative. Okay, now since my scale is on 1/4, I'm going to go by 1/4. So I have 1/4, 1/2, then 3/4, then 1, then 5/4, and 3/2. Okay, at 1/2, I'm going to start at 0. Then at 3/4, I go all the way up to 7. And at 1, back down to 0. And then at 5/4, down to -7. And then at 3/2, back up to 0. So here's my graph of the translated function. Let's go ahead and put this in on the calculator so that we can check it. Okay, first let's go to y equals and clear out what we had in there from the last example. And let's put in our new equation. Our new equation is 7 sine, and then we have 2 pi x. And then minus pi. That was our original equation. Now I want to go and adjust my window to make sure we did this correctly. Our first point, our starting point is at 1/2. So I'm going to put our x min at 0.5. And our stopping point we said was 3/2 or 1.5. So for our max, I'm going to put 3/2, or you can do 1.5. And we wanted to do this on a scale of 1/4, or 0.25. For our y minimum, since our amplitude, we go all the way down to -7 for our minimum, and then we go all the way up to 7 for our y max. And we can keep that on a scale of 1. Or actually, since we did it on a scale of 2, we can change it to 2. Okay, once I have the window set up, I'm going to hit graph and make sure that we see that full cycle. So we see where it starts on the x-axis, it goes up to our max, goes down to our min, and then comes back up to our x-axis. So seeing that full cycle on there, just like what we just graphed by hand, we know that we did it correctly. In this example, we're graphing a translated cosine function. So if we look back at our mother function for cosine, we start at 1, then we hit our x-axis, then we dip down to our minimum, then we hit our x-axis, and we come back up to our maximum. So our cosine, when we look at the first cycle, looks kind of like a bowl, or maybe if you want to look at it as a valley. Now here's the thing I want to also point out to you, that notice this graph, the translated graph or the translated equation, has a negative in front. So that tells me we are going to flip this graph upside down. So all of our minimums are going to become maximums, and all our maximums are going to become minimums. So when we flip this graph upside down, after we translate it, it is now going to look like this. I'll do the translated one in blue. So it's going to start down here. It's going to hit the x-axis and come up. And it's going to come down and finish at a minimum. So although it has the same shape, it's going to be flipped upside down because of that negative. And again, the only thing that's going to change is that our maxes and our mins get swapped. Okay, so if we look at our amplitude tells us how far it's going to come out from the midline. And in this case, it's 4. So instead of coming out to our max and our min at 1 with our mother function, we're going to come out to 4 from the midline. Now to find our period, we need to put this in the form so that we factor out the b. So I have negative 4 cosine. I'm going to factor out the 4. So 4 is our b. And when I do that, this is what I get. So our period for the translated function is going to be the original period divided by our value of b. Now, since we're dealing with cosine function, I got to think back to what my period is for the mother function for cosine, which is 2 pi. And my value of b here is 4. So the length of my period, when I reduce that and clean it up, is going to be pi over 2. So my full cycle is going to have a length of pi over 2. So we just shrunk that by a factor of 4 is what we did. So normally we have, here's our compression here. Normally for our mother function we have a period of 2 pi, but we're cutting it by 4. We're squishing it down by a factor of 4, which will give me the pi over 2. Now the phase shift is this right here. That tells me that when I start, instead of starting at 0, I'm going to bump it over pi over 4 to the right. And my scale is always going to be the length of my period chunked into 4 pieces. So when I look at my mother function, these are my key points here. And that's going to cut it into this piece, this piece, this piece, and this piece. Those are my 4 chunks. Okay, so I'm going to take my translated period and divide by 4. So pi over 2 divided by 4 will give me pi over 8. So I'm going to scale this at pi over 8, and it's going to start at pi over 4. And the whole length of my period should be pi over 2. So normally we start at 0, but it says we're shifting this to the right by our phase shift. We're going to shift it to the right, pi over 4. I'm going to keep adding pi over 8. So if I take pi over 4, and if you have to do this on the side with scratch paper and find a common denominator, that's totally fine. If I take 1/4 and if I take pi over 4 and I add pi over 8, that's going to give me 3 pi over 8. And then if I add pi over 8 again, That's going to give me a half pi. And if I add pi over 8 again, that's going to give me 5 pi over 8. And then if I add pi over 8 one last time to get the end value, that's going to give me 3 pi. That's going to give me 3 pi over 4. Now, you can check to make sure you have a length. Remember, your period should have a length of pi over 2. So if you're not comfortable with the scale, you can double check it by subtracting. If I take my endpoint, which is 3 pi over 4, and I subtract my starting point, that should give me the length of the whole cycle. Well, 3 pi over 4 minus pi over 4 would be 2 pi over 4, which is pi over 2. So it works. This full length from pi over 4 to 3 pi over 4 is pi over 2. Now, since we know that this is getting flipped upside down because of negative in front, I'm going to look at this second graph here in blue. I'm going to look at this second graph in here in blue because it gets flipped upside down. So normally at the starting point, we would go up to 1 for a mother function. But since it's flipped, we would go down to -1 instead. Our maxes and our mins get switched. But then in addition to that, because it's stretched out by a factor of 4, that's my amplitude, my minimum is going to be -4. So I'm starting here because it's been flipped upside down. Then I go to my x-axis, which is 0. Then I go to my maximum point, which in this case would be 4 because it's been stretched out by a factor of 4. That's my amplitude. Then I come back down to my x-axis, and then down to my minimum point, which is -4. So I'm going to go up 1, 2, 3, 4, and down 1, 2, 3, 4 on my y-axis, because I'm going to go out in either direction 4. Now on the x-axis, I'm going on a scale of pi over 8. So I'm going to start at pi over 8, and I just keep adding pi over 8. When I add pi over 8 and pi over 8, I get pi over 4. When I add pi over 8 again, I get 3 pi over 8. When I add pi over 8 again, I get pi over 2. When I add pi over 8 again, I get 5 pi over 8. And one last time when I add pi over 8 one more time, I get 3 pi over 4. And that's as far as we need to go. So now, when I graph pi over 4, -4, I get this point here. And then I come up to 0. Then at pi over 2, I hit my max because this has been flipped upside down. Don't forget, normally the cosine looks like a bowl, but this time, or a bowl or a valley, so the center point would be the lowest point, but because this is a reflection over the x-axis, it gets flipped upside down, and so now it looks like a hill instead of a valley. At pi over 8, we come back down to 0, and then at 3 pi over 4, I come back down to my min. So this would be one full complete cycle. Now let's check it on the calculator. Okay, so let's clear out what we already have in there. I'm going to go to y equals and hit clear, and I'm going to put in our new function for this example, which is negative, don't forget to hit the negative, not the minus sign, -4 cosine of 4x minus pi. And close parentheses. And then I'm going to go to the window, and I'm going to make sure we adjust our window. If we look at our first cycle, it starts at pi over 4, so that should be my x min. I'm going to put in for my x min pi divided by 4, and it will automatically change it to a decimal value for you. My maximum, if you look at the ending point of my cycle, that's going to be at 3 pi over 4. I'm going to choose 3 pi divided by 4. And we're doing this at a scale of pi over 8. So I'm going to put in pi over 8 for my scale, for my x-axis. And my x-min is going to be -4. And my x-max is going to be +4. Now, we did this on a scale, for the y-axis, we did this on a scale of 1. So I'll just change that 2 to a 1. And now I'm going to go ahead and hit graph. And if we did it correctly, we see the upside down bowl for our first cycle. That's exactly what we just graphed by hand. And so we did this correctly. We got the right scales, we got the right period, and we can see all the major features of the first cycle. Okay, the last example of graphing by hand, notice I wanted to do one that did have a vertical shift. This has a value of d in it. So whatever our points are going to be at the very end, we have to subtract 1 from all our y values and bump everything down 1. So the amplitude in this case is going to be 3. Notice there's no negative in front, so we don't have to do a reflection over the x-axis and flip it upside down like we did the previous example. Just remember, if you see a negative in front, everything gets flipped upside down and maxes become mins and mins become maxes. But we do have a shift down. So we have to remember to do that in the end. Now this is the sine function. So if we look at the graph of our mother function of one cycle, it will look like this. When we graph it at the end, it's going to be bumped down 1 unit. So it's going to end up looking like this when we bump it down. So just keep that in mind. Okay, our period, remember our period is going to be the original period divided by our value of b. In this case, our value of b is 1/2. And because this is the sine function, the mother function sine has a period of 2 pi. So I'm going to take 2 pi and divide by 1/2. When I divide by 1/2, I have to flip and multiply because I have 2 pi divided by 1/2 means 2 pi times 2 over 1, which is going to be 4 pi. So the length of this translated function is now doubled. Instead of having 2 pi, it's going to be 4 pi. It's just doubled because of that 1/2 in front. Now, because I don't have a minus c in here, notice inside the parentheses, I don't have a minus or a plus something in there. There's no shift. So no horizontal shift. So it's going to start at 0. The scale is the new period of the new function, not the mother function, the new function, divided by 4. So I'm going to take 4 pi divided by 4, and that's going to give me pi. So if I look at my mother function, I have the 5 key points that splits it up into 4 chunks. 1, 2, 3, and 4. Okay, so there's no horizontal shift here, so it's going to actually start at 0. And if we look at the mother function, typically we start at the origin. But because we have a shift down 1, it's now going to start at -1. Our next point would be pi. Since we're doing this on a scale of pi and it starts at 0, I just have to add pi to 0, and I get pi. And normally, if we look at the mother function, that's where we would have our maximum point. And our maximum point would be 3, because our amplitude is 3, but then we bump it down 1 because of that -1, that vertical shift, which would give me a 2. Now we add pi again because we're doing this on a scale of pi, so I come out to 2 pi. And normally that's where we come back down and hit the x-axis. So if we look up here, normally that's where we come back down and hit our x-axis. So that would normally be 0, but then because we bump it down 1, that's going to be at -1. then my next value would be 3 pi because I keep adding pi. Our next point would normally be our minimum point on the mother function at -3 because it's an amplitude of 3. But then I've got to bump it down 1 because that -1 in the end for the vertical shift, which would give me a -4. And then the last point, which is 4 pi, which is typically where we come back up to 0, but because of the vertical shift down 1, it's only going to come up to -1. So our new midline in this case is going to be y is equal to -1. So typically where you have all your zeros, you're now going to have all -1 because everything has been shifted down 1. So now let's plot this by hand. The lowest I have to go is -4. And the highest I have to go is +2. And I'm doing this on a scale of pi. So every 2, I'll make it worth pi. Okay, so at the point 0, I come down to -1. At the point pi, I come up to my max, which is 2. And then at 2 pi, I come back down to -1. And then at 3 pi, I go all the way down to -4. And then at 4 pi, I come up to -1. So if you notice, this is my new midline instead of the x-axis, because everything's been shifted down 1. So this is what my new, or my translated graph looks like. Now let's check it on our calculator. Okay, let's go ahead and clear out what we did previously and put in our new equation. So we have 3 sine, and then in parentheses a half, which I'm just going to put in as 0.5 x, close parentheses, and then -1 for my shift down 1. Make sure that -1 is not on the inside of the parentheses because that's a completely different graph. That would mean that would give me a value of c where something is shifted horizontally. It's got to be on the outside of the parentheses if it's going to be a vertical shift. Now I'm going to go to my window and I'm going to make sure I adjust everything accordingly. Our period starts at 0, so I'm going to do my x min is 0, and it ends at 4 pi. I'm going to hit 4 pi, and we're doing this on a scale of pi. My y min, the furthest down I need to go is -4, and the highest I need to go is +2. And I did that on a scale of 1 for my y-axis. And now I'm going to hit graph and make sure I see what I'm supposed to see. So as you can see, our new midline in this, let me actually graph it for you, is at -1. If I go ahead and graph that, just a horizontal line at -1, that's my new midline. So think of this as the new x-axis. Okay, everything's been bumped down. So at all the pi's, at 0, and then pi, and then 2 pi, and then 3 pi, and 4 pi, it's all based off of that line -1. Right? Here's where I normally would start at 0, but it got bumped down 1. Here's where I normally would go up to an amplitude of 3, but it got bumped down to 2. Here's where normally it would go back and hit the x-axis, but it got bumped down 1. Here's normally where I would have my minimum at -3, but it got bumped down 1 more to -4. And then when I come back up at pi, at 4 pi, it normally would come up and hit the x-axis, but it got bumped down 1 to -1, since that's my new midline. Okay, in the last 3 examples, we're going to actually work backwards, where we are given the graph, and we need to determine what the equation is. So if you recall, the mother function of cosine, the graph looks like this for the mother function. And then if it's been flipped upside down, if we have a negative in front of it, it will look like this. Or instead of starting at the max and dipping down, we're going to start at the min and go up. So for the mother function without a reflection, it's going to look like a valley. And for the mother function with a reflection, it's going to flip upside down, so it's going to look like a hill. Now for sine, the mother function starts off at 0, 0. It goes up to its max, it comes down to its min, and then it comes back to the midline, or the x-axis. If there's been a flip, then the maxes and the mins change, so instead of coming up first, it's going to go down first, if there's been a flip. Okay, so you need to know those basic shapes so that we'll be able to identify what equation that we're going to use. So if we look at this first example, this looks like an upside down bowl or a hill. So this is going to be a minus cosine function. It's going to be the cosine function, but it's going to be flipped upside down. Notice the midline, which would be the center coming up through, is the x-axis, so it hasn't been vertically shifted. The amplitude is going to be 1/4. So from the center out in either direction to get your min and your max, you're going to go 1/4. Notice that it also has been shifted to the left pi over 3. The last thing we need to look for is period of the translated function. So from minus pi over 3 to 2 pi over 3, that's a length of pi. And if you can't do that in your head, you can just take the ending point and subtract the first point to find the length, right? So I would take 2 pi over 3 and I would subtract a negative pi over 3. And that would give me a length of pi. In order to find out our value of b, remember the new period, which in this case is pi, is equal to the original period, which is 2 pi, divided by our value of b. So if I take 2 pi divided by b, and I get pi, which is our new period, our value of b would have to be 2. Right? 2 pi divided by 2 would give me the new period, which is pi. So now we have everything we need. We have minus 1/4, because 1/4 is our amplitude, our value of a. Cosine, my value of b, which is 2, and then x, and since we're moving to the left pi over 3, that's going to be a plus pi over 3. So this is the equation for the graph to the left, the first graph. Now you can always go into your calculator and check it by putting in the appropriate scales. You would put in your equation, then you would put in your x min is negative pi over 3, and your x max is 2 pi over 3. You would put in your y max as 1/4, and your y min is negative 1/4. And you put all that information in, and you graph it, and you make sure that you get the same picture. Okay. The next picture is also a cosine. I notice I have the shape of a valley. So that means I'm going to have the original, I'm going to have the cosine function without a reflection across the x-axis. So I don't need to put a negative in front of it. So I'm going to be using this function. Notice, however, that my midline changed. The line that should go down the center of it horizontally is not the x-axis, it's the line y equals 1. So this graph has been shifted up 1. So d is going to be 1 later when we put that in. Our amplitude is the distance from the midline out to the max and out to the min. So if I look at my midline and I go up to the max, that's a distance of 1. And if I look at my midline and I go down to the min, that's a distance of 1. So my amplitude is 1. That's my value of a. I know that D in my equation is going to be 1 because everything's been shifted up 1. And if we fill in the missing scales, they don't put it in here, but it looks like they're going on a scale of pi over 8. Because half of pi over 4 would be pi over 8. This would be negative pi over 8. And then this would be 7 pi over 8. So I would just take 3 pi over 4 and add pi over 8, and I would get 7 pi over 8. So if I go from negative pi over 8 to 7 pi over 8, that has a length of pi. So my period for my translated function is going to be pi, which means my value of b needs to be 2. Because my new period, which is pi, is going to be my old period divided by b. So b has to be 2. And then it looks like it's been shifted to the left, pi over 8. So that gives us all the information we have now, and we can make our formula. So my formula, or my equation for this graph, is going to be 1 for my amplitude, 1 times cosine, my value of b is 2, x plus pi over 8, because it's been shifted to the left, so that means it's going to be a plus pi over 8. And then everything's been bumped up 1, so then I have to add in the plus 1. So here is my equation for the graph above. And again, you can go through and graph it on your calculator to check to make sure you've got it right. So for your x min, you would put negative pi over 8. For your x max, you would put 7 pi over 8. And then for your y max, you would put in 2. For my y min, you would put in a 0, because it goes from 0 to 2 for y, and it goes from minus pi over 8 to 7 pi over 8 for x. The last graph is the picture of the first cycle of a sine function. And it's not going to be reflected, because if it was reflected, it would start at the x-axis and dip down first rather than dip up. So dipping down for sine first would be a reflection. Now, if we fill in these missing scales, half a pi would be pi over 2, and then half a pi over 2 would be pi over 4. If I fill in some of these gaps here, if I take 2 pi and I add pi over 4, that's going to be 9 pi over 4. My whole length, my whole period for this new function is 2 pi. If I take 9 pi over 4 and subtract pi over 4, that whole thing is 2 pi. It's just been shifted over pi over 4 to the right. My amplitude is 4. Notice that my midline has not changed, so there is not a vertical shift. My center is the x-axis, so I know there's no vertical shift. And so if I go from my midline out to my max and my min, that's a distance of 4. So I know my amplitude is 4. Now, since my period is 2 pi, I need to find out my value of b. If you recall, the new period, which is 2 pi, is the old period divided by my value of b. So b in this case would have to be 1. So my equation for this is going to be y equals my value of a, which is my amplitude, 4. This is a sine function, so I'm going to use sine. My value of b is 1. And then I have x, and I'm moving pi over 4 to the right, so it's going to be x minus pi over 4. So here is my equation for the last graph. And so if you want to put this in the calculator and check it, you would put in your x min is pi over 4, your x max is 9 pi over 4, your y max is 4, and your y min as negative 4. And you should get that picture.